I apologize for that. Let's look at the 2.3, okay? The composition of the function outer G will be the inner. You can write down the G of X, or you can just write down F of G, okay? So there's two ways to do this one, actually. And I showed you the shortcut last time. I don't know if you still remember, but basically, we're going to look at the two different ways to do this one, okay? So with the composition of the function, this is kind of like going through the two machine, all right? So when you have a F composite G of X, okay? F is the outer, G is the inner. So you have a G machine, all right? So this is the inner machine. You go through the inner first, and then you come out to the outer one here. So you throw the X into the G machine, right? Just like if you want to make a chocolate candy, now you're gonna need to have some powder, right? So this is chocolate powder, things like that. And then you go to the G machine, you mix with some sugar, all right? So now when I come out the G machine, right? So when you have a powder, go through the mix up with the sugar. Now you come out with this sugar chocolate powder, right? But we want to make a candy, so we're gonna go through this F machine. Maybe this will make a triangle or make a heart shape, whatever you have right here, all right? And then you come out with this piece of the chocolate, that one, which is sweet that way, okay? So that is two machine. You go through the G machine and then come out with the sugar powder and then come out with the F machine, and you have a different shape of the chocolate. All right, so that is a kind of composition. You can kind of think it's going through the two machine that way. All right. This is the composition like the F composite G, right? So you actually go through the two machine. This is the same flow chart as the one we have earlier, just using a different row, all right? So F go to G machine and you got a G of X, right? And then go to the F, you come up with a G of F of the G of X. So this is the F composite G, all right? So giving you a little bit concept in here. This one right here is if you have a f of x is 3x minus 1, right? And then I have a g of x is equal to x squared plus x minus 3. We want to find a f composite g, and then we also want to find g composite f, okay? So where's the f composite g? Well, basically, this f will be the outer. Look at the f will be the outer, g will be the inner, okay? And I'm showing you, you have two different ways to do. All right, so what are the two different ways? The book is going through the step by step. All right, so you plug the g of x in. So g of x, how much is g of x? G of x is x squared plus x minus 3, right? And then you're gonna come back. So g of x is equal to this one, and then you come back to the f machine here. All right. So this F machine is whatever this you input, you're gonna come out 3 times this whatever minus 1. Okay, so this star x can be changed into like a star. All right. And then this is 3 star minus 1. So this will be 3 star. This whole thing is a star, right? 3 star minus 1, 3 star minus 1. Okay, and then I'm going to put a star in. All right, my star here is x squared plus x minus 3. All right, and then you can just simplify, multiply it in, right? So 3x squared plus 3x minus 9 minus 1. So I have a 3x squared plus 3x minus 1. So this is the f composite g of x. All right, you can do this way, just like the book, usually the video from the book or the example from the book is doing this way, okay? And I showing you a shortcut earlier. Last time in the review, I showing you the shortcut, right? So what's the shortcut here? So I'm gonna doing the second way, and you can see it come out exactly the same. All right. So f composite g of x. F is the outer, G is the inner. So I can just write down this one. And I'm going to F directly. So I'm going to F directly. And I just change this X into G. All right, so this should be really easy. So I'm gonna have a 3g minus 1, okay? Change x into g. So I have 3g minus 1, right? And then eventually I put a g back. So g is x squared plus x minus 3. And then you can see these two steps are the same, right? So 3x squared plus 3x minus 9 minus 1, and then these two together is the like term. All right, so you can come out exactly the same. So whatever way you feel is more comfortable to you, whatever way you feel a little bit easier to you, that's the way you can go. Okay. If you feel the book way, which is this way, is the book way, it's easier. That's fun. All right. But when I was doing the in-class, in-person class, some people got confused in this one. And when I introduced this one, they kind of like it that way. All right. So they kind of think, yeah, F is the outer, F of the G, right? So now I just change the X into G. So that's really easy. And then eventually, oh yeah, and I put a G back. Okay. So either way will work. All right. It's just whatever way you feel more comfortable. And if you don't want to learn two way, you can just stick in one way. That's totally fine. All right. You can stick in one way and then do whatever way you want. All right. Let's look at the B. Okay, so the B here, I'm gonna write down in here. The B here is G composite F. All right. So you can see if I do the second way, it's really easy. So this will be G of F. G is the outer, F is the inner. So I'm going to the G function directly. So going to G, just change X into F. So change this X into F, right? So now this will be F squared plus F minus 3. Okay, I just change the X into F. All right, and eventually I plug the F back. Okay, so F is 3x minus 1 plus F here is 3x minus 1 minus 3. All right, so this one you don't need to simplify, right? Simplify, get rid of a perfect square. Okay, so if you have a perfect square, A plus B perfect square, and I hope everyone remember this formula, okay? This actually is A plus B times A plus B. And then if you go to do the FOILs, this AB multiplied together, you're gonna have A squared plus 2AB plus B squared. So basically 2 times 2, you're gonna get 4 terms, right? 2 items times 2 items, you're gonna get 4 items. And then because the middle term, the inner and the outer, they all multiply equal to AB, they are the same term. So you combine them together is 2AB. All right. If you have A minus B squared, everything is the same except the middle term become the minus 2AB. Okay. So this is considered the perfect square formula. And I do encourage you to remember this formula because it used a lot. It's different than the A plus B times A minus B. This is not a perfect square, right? Because one is plus, one is minus. And then this one, if you simplify, this will be just A squared minus B squared because this is positive AB and then this one will be negative AB and then they cancel out. That's why only 2 terms there. All right. So these 3 formulas do not confuse each other that way. If you understand this formula very clearly, your algebra will become much easier. All right. Especially this one, you can also do the factoring. All right. So I do have a little bit video for the factoring, like x squared minus 2 squared, right? This is like x squared minus 4, right? And then 4 you can write down as 2 squared, so I can factor into x plus 2, x minus 2. So that's called factoring in here. All right, even x squared minus 1, you can still factor into x plus 1, x minus 1, because 1 is a tricky one. 1 you can see as 1 square. 1 square is still equal to 1. All right, So this formula, you can do the factoring, or you can just multiply together that way. All right, and then these are the perfect square. Perfect square is a minus b times a minus b is the same. All right, this is the same base multiply itself twice. This one is the same base plus, and this is also plus. Okay, this one is called the difference of the square. The difference of the square in here, because look at this one right here. One is plus. Okay, this one is plus, and then the other one is minus. So this one is not equal to this one or that one. Okay. All right, so now we're gonna come back here. This is the first term, so this will be 3x squared minus 2 times 3x times 1 plus 1 squared, right? This is just for the first one, okay? And then, of course, we have to plus 3x minus 1 minus 3. All right, and then this one will be 9x squared, okay, minus 6x. 1 squared is still 1, right? And then plus 3x minus 4. All right. And these two are the like terms, so we're gonna need to combine them together, right? And then 1 and negative 4, combine them together. So that is the final answer, okay? So you do need to simplify the final answer that way. All right. Any questions? So that is the composition, okay? We just do this one earlier in here, all right? 9x squared minus 3x minus 3, so we got exactly the same answer, okay? If you want to plug x equal to 2 in, and if you already found out the equation, right? You already found out this composition equation, you just plug x equal to 2 in, all right? So if you want to find the G composite F of 2, what do? Well, I already have this composition already found out, so I just need to replace the x by 2. Okay, so 2 squared is 4, 36 minus 6 minus 3, right? So this will be 30 minus the 3, 27. All right. So that is the composition, right? If you already find a composition function, you just replace the x by whatever number in here. So it's really quick and easy that way. Same thing as the other one, okay? So you don't have to go through step by step to calculate that way. All right. I want to talk a little bit is the this kind of domain and all the consider the okay, consider the even loop. All right, so domain, basically domain, sometimes people consider domain is very complicated, but actually it's not. Domain only need to require 2 conditions. One is denominator. All right, cannot be 0, okay? Remember I tell you these 2 words, no. This one is a no, right? A number divided by a 0 is a no. This is called undefined, all right? So denominator cannot be 0, all right? If I have a f of x equal to 1 over x minus 2, okay? So this one denominator, what's the domain for this one? X minus 2 cannot be equal to 0. So if you solve this one, x cannot be equal to 2. All right. So how do you write down the interval notation? Sometimes people still didn't know how to write the interval notation or making mistake, right? Interval notation, if you have a 1 point, you're gonna cut the line into 2 pieces in here. So you have an interval 1, interval 2, okay? And these 2 need to be circled out. So when you have a not equal, you have to use the parenthesis. And the interval always is smaller number on the left, smaller number on the left, large number on the right, okay? If you write down the all real number, so how do you write down all real number? From negative infinity to positive infinity. Negative infinity is always the lowest number, so you always on the left. Positive infinity always the largest one, so this is always on the right. Okay, if you write down this one is totally wrong, that is the wrong one. All right, because this one you have a largest number on the left, or small number on the right, so that's the wrong one. You always have to write down smaller on the left, large on the right. Okay. This one, you're going to have a negative infinity to 2 parentheses, okay, and then 2 to positive infinity. If you write down 2 and negative infinity, that's also wrong, because negative infinity is always on the leftmost, okay, that's always the largest one. Positive infinity is always on the rightmost, because that is always the largest number. All right. So that is a little bit interval notation. If you have x greater than 2, less than or equal to 3, right? 2 will be parenthesis, 3 will be bracket, because 3 has an equal sign. All right. Negative and positive infinity, you always using the parenthesis, because you can never ever equal to the infinity. Okay, so always parenthesis that way. All right, so that's how you write down your interval, right? And second one right here, domain rule number 2. Okay, so this is rule number 1. Denominator cannot be 0. Rule number 2, if it's under the even root. So what kind of root is even root? Square root is even root. Fourth root is even root, right? How about Q root? Well, Q root, this is not an even root. This is R root. R root, domain X can be anything, all real number, because we can have a -1 cube is still -1. Or I take the -1 cube but still -1. All right, so negative R root, it can be all real number. All right, one thing is the even root. Even root X here can only be positive. That means it cannot be negative. All right, same thing as a fourth root. That's all even, not an event, even. Okay, let me get rid of this one. Even root. All right, the even root, x, the radicand. So what is a radicand? Anything under the root is called radicand. It has to be greater than or equal to 0. It can be 0. Unless it's on the denominator, it cannot be 0. But when it's not in the denominator, this x can be greater than or equal to 0. And that is your domain, right? So if you go to write down the interval notation, it will be from 0 to infinity. All right. And it's only 2 rules, okay? All right, so now let's look at this composition, okay? The composition here, first, we need to, in order to find the domain here, you actually have to do the calculation first, okay? F composite G, F will be the outer, G will be the inner. And one thing here is you also have to look at the 2 domain. This is called the input domain. And then the whole thing here is output domain. The whole composition is the input domain. Input domain, that means I want to see what is in the G of X, because my G need to put into the F, right? So G first have to be defined. So yeah, G is 2x plus 3, X is not. So my G of X, X is not in the denominator, X is not in the root. So that means my input domain can be anything. My input domain can be all real number. So I don't have to worry about that one. Okay, so we're gonna go to the F, right? So go to the F. So this will be fourth root of G, okay? Replace the X by G. And then we're gonna put a G in. All right, G in. G is 2x plus 3. So that is the composition, okay? This F composite G of X is equal to fourth root of 2x plus 3. All right. And we said earlier, this is an even root. This is an even root. All right, even root radicand. So it's not just the x, but the entire thing, entire 2x plus 3, need to be greater than or equal to 0. All right. And then we go to solve for X, and that is your domain. We already checked the input domain. The input domain G can be anything. So we just need to consider the output domain here, right? And then solve for this one, minus 3 on both sides. So we have a 2x need to be, 2x will be greater than or equal to -3. And then you divide it by 2. Since the coefficient 2 is a positive number, so you don't change the inequality direction. So this x will be just greater than or equal to -3/2. All right. If you do a little bit number 9, negative greater than or equal to is going to the right-hand side. All right. So this -3/2 is the smallest number. The large number will be infinity. Okay. So that's how you write down the domain. If you put if you write down the opposite way, opposite order, it will be wrong. Okay. So you have to always remember smaller number on the left. Smaller number. This one is smaller number on the left. All right. That is this kind of domain in here. Any questions? Okay, how about if I'm gonna just using this one as an example, okay? How about if I have a G comp GF? Okay, we're gonna consider this is part B. G comp GF. And what is the domain for this one? Will this domain the same as this one? Apparently, it might not be the same because now I have a different composition, different order. When I have a different order, it comes out something differently, right? So now I'm gonna have a G is the outer, F will be the inner, okay? All right, we have to consider the input domain. So my input is F. F is my F here. So that means you cannot throw the junk into the machine, right? So my F, this is called the input domain. Input domain. All right, domain, you have to consider the output and input as well. All right, where is my, oh, right here. Okay, all right, so this is the input domain. Now my input domain earlier, G input can be anything because X is not in the denominator or under the loop. But right now, my input F here is force loop. My F here is force root of X. So this is an even loop. So my input domain here, X has to be greater than or equal to 0 because this radicand is only 1X. So X has to be greater than or equal to 0. So we have to keep this one in mind, and then we're gonna combine our output later on together, okay? And then let's go to the G. G is 2F plus 3, okay? And F here, so F here is force root, all right? Force root of X plus 3. All right, so this is called my output, okay? Everything is done. This is the output. And then we're gonna look at the output domain. Well, this output domain is also under the force loop. All right, so X also has to be greater than or equal to 0. So actually my input domain and the output domain is exactly the same. All right, so I don't have to do anything modification. So this will be, they are the same, they are both, so the domain here will be 0 to infinity. So that will be the domain for G comp GF. So you can see there's a difference in here. This one is F comp G, this is a domain, right? G comp F, this is a domain. All right, any questions? Okay, we're gonna look at this one right here. Okay, so this one right here is say, I'm going to decompose this one. So look at it. If I have a h of x equal to 3x minus 1 to the power of 4, right? And then we're gonna find the f of x and g of x such a h of x will equal to f composite g, and then that means f composite g will equal to this one. All right. So we can see this one, F will be the outer, G will be the inner. All right. So if you go to look at the outer in here, this outer is something to the power of 4. So outer one had to be something, x to the 4 power. And my inner one will be this detail, 3x minus 1. So if I look at this one right here, we can check that back. If I have an F compared to G, do I get this one back? Okay, F compared to G, F will be the outer, G will be the inner, right? So go to this one will be G to the 4. Go to the F function, replace the X by G. So G to the 4, and G is 3X minus 1. So yeah, I did got it back. So this is how you break it down. So my breakdown, the outer one will be x to the 4 power. My inner one will be 3x minus 1. Okay, and then these two composite together, we are giving you the h of x equal to this one. All right, so that is how you showing you this one in here. I want to give you a little bit practice here. Is let's look at one of these. Okay, a little bit fraction. I know people usually do not like a fraction. Okay, but I want you to practice at least one of these, like the first one. Okay, and then we also find a domain. Okay, find a domain for these two. All right, if you can do this one correctly, that means you pass this whole thing. Pass this section, right? Okay, so let's look at the first one. F composite G. All right. So the first one right here, I have a F composite G of X. I will write down F is the outer, G is the inner. Okay. And what is this G will be the input domain. All right, input domain. Remember, we said earlier, domain, we have to consider input and also the output. My input domain here, since G is equal to 1 over X, this X is in a denominator, right? So X cannot be 0. Okay? We said earlier, remember I telling you these two earlier. Remember the domain here. Denominator, domain rule number 1, denominator cannot be 0. Rule number 2, if it's under the even rule, radicand has to be greater than or equal to 0. Okay, so that is this one in here. This one, that's the input domain. So we're gonna keep this in mind. We're gonna combine with our output later on. Okay, so I'm going to my F here. I'm going to my F, replace this X by G. All right, so this will be 4 over 1 minus 5G. Okay, and then we cannot keep the G, we have to replace G by the X. All right, so this one, we have a 4 over 5 times G. G here is what? G here is 1 over X. So times 1 over X. All right, listening to times 1 over X. All right, 1 over X, I can write down this one is just 5 will be on the numerator. X will be in the denominator. Basically, it's just 5 times 1 over X. All right, and this one is called complicated fraction because now you have 2 bars in here. If you type this one in the homework in the MindLab math, it will counter you wrong because you cannot have a 2 fraction. We have to simplify, okay? And quick and easy to simplify this one is just we call multiply by 1. So what does multiply by 1 mean? I can multiply the denominator x. Look at it. If I multiply numerator and denominator both by x cancel out, right? So it equal to the previous one. But once I do this one, I can simplify my denominator, okay? All right, so this 4 times x will be 4x. 1 times x will be x, and then this x cancel out, so this will be minus 5. Look at it. This is simplified really quick. All right. Or you can go to do the LCD for the denominator, but you're going to have to use 4 divided by equal to multiply the reciprocal, right? You will get the same answer. But by multiply by x is much easier. So this is my output. All right, so what is my output domain? Well, my output domain is another fraction, so x minus 5 cannot be equal to 0. You go to solve for x here, that means x cannot be equal to 1 or to 5. But now you also have to consider this input domain and output domain. These two are different, so we need to combine the two together in here. We're going to have to have a 0 and 5. So x cannot be 0, x cannot be 5. All right, so 2 point going to cut the line into 3 pieces. This will be 3 pieces. All right, so your domain here going to be from negative infinity to 0, and then unit from 0 to 5. And then unit from 5 to infinity, because this is going to cut into 1, 2, and 3 pieces in here. All right, so that is the domain by using the input and the output. Combine the input. You do need to consider the input domain, because this input domain and the output domain is different this time. All right. When it's different, you have to combine them together. So x cannot be 0, x cannot be 5. Any questions? All right, let's look at if I have a G composite F. Let's see what's different. All right, if I have a G composite F in here, my G will be the outer, my F will be the inner, right? And then we're gonna have an F here, this F here, this is the input domain. All right, so we're gonna have to go to look at what is my input domain. My input domain here, we have a 4 over 1 minus 5x, so we do have a denominator. That means 1 minus 5x cannot be 0, right? And then if you go to solve this one, subtract 1 on both sides, divided by negative 5, so x cannot be equal to 1 over 5, right? You add a 1 not equal to 5x, add a 5x on both sides, and then divide by 5. So x cannot be equal to 1 over 5. So that's the input domain. All right. And then let's see what is my whole output here. We're going to go to G. Replace x by f. Replace this x by f. So this whole thing will be 1 over f. Okay? 1 over f. And what is the f? Well, f is this one here. F is 4 divided by 1 minus 5x, right? So this one is just flip over 1 divided by this one is 1 equal to multiply the reciprocal. So that is this one. Okay, so that's your output. Your G composite F output here is 1 minus 5x over 4. What is my output domain? Well, my output domain actually is fun, right? Because I don't have an x in the denominator. My denominator is just 4. 4 will never go to 0. And I don't have a square root, any even root. So my output domain can be all real number. So basically, I just need to consider this one. The whole domain here, just x cannot be equal to 1 over 5. Okay? So if you have a 1 over 5, you cut into 2 pieces. So this will be from negative infinity to 1 over 5, parentheses, okay? And then 1 over 5 to positive infinity. So that way you can get rid of this point in here. All right, so that is the output domain. My output domain can be anything, but I have to restrict by the input domain here, okay? So that is giving you the fractions. The fraction that's probably the most complicated one, right? You have both f and g, both are fraction. All right. The rest, this one, second one is very similar to the first one. All right. And then the third one actually is a little bit easier than that. All right. Any questions? Okay, let's do one of the decompose again. All right, so let's look at this one right here. How do I decompose this one? Okay, h of x will have a write down as f composite g, right? So if you look at this one right here, what is my big picture here? My outer actually is some kind of Q loop. Okay, and then where's my inner one? My inner one will be this inside one. All right, and then if you go to using f composite g, f will be the outer, g will be the inner, right? So you're gonna have a Q loop of g, and then plug a g in, Okay, so you got exactly this one. So that means these two decomposition is the correct one. All right, so actually the decomposition actually is pretty straightforward. And I'm gonna decompose this one, right? So where's my decompose this one right here? My decompose this one is my outer looks like a fraction. All right, 1 over x to the 4 power. Okay, 1 over x to the 4 power. And my g over x will be just this inner one, x minus 2. Okay, so if I want to double check, I double check f composite g. Let's see what we have. F will be the outer, g will be the inner, right? So we're gonna have a replace the x by g. So this will be g to the 4 power, right? And then g is x minus 2 to the 4 power. So you got this one back. All right. So decomposing actually is a little bit easier, in my opinion. All right. I think for today, since the chapter 3 won't be due until for another week, and then this week you will need to concentrate on the chapter 1 and 2 for the test. So I think I'm going to leave the chapter 3 review for next time. Okay, we don't have much time left, so I think I'm not trying to overload you too much for the chapter 3. I think if you can do the chapter 1 and 2, do the first test well, it will give you much more confidence to move on. All right. So the first test is very, very important. Okay. If you do the first test well, usually you have a much more confidence that way. All right. So I want to just start by here today and then let you go to focus on this test. Okay. Remember, you have to finish all the homework and the review first before you can open the test. All right. Don't do the opposite way. If you didn't finish the homework and the review, you won't do the test well. All right. So always make sure you do the homework and review first. And then you might come back to review this video and also the review video I sent you last time. I also posted another review. Well, it's the same review, just not an introduction, okay? And let me show you, I also posted this one right here. Okay, I posted another to the announcement here. I also just posted you the another review. All right, so this is the recap, right? And then this recap, you got everything in here, okay? And I also posted another one right here. Test one review. Yeah, this one right here. Okay, I also posted this one right here. This one right here, I posted on the YouTube in here. This one is you don't have a net introduction. Everyone's introduction in there, right? And then you know you can just get straight to the review section and the homework. Okay, so you might want to go ahead and also review this one more time just in case. I think this one is very, very close to the test question. All right, pretty much all the question type are in here that way. Okay, and then plus this is a little bit more concentrate on the composition, which is the new one for the chapter. All right. Okay, so I am going to start the recording. Any question? I will still stay online for a while. If you have any question, otherwise you're gonna just go to get ready, finish everything, and then finish the test. All right, and I will meet you next Tuesday again. Okay, I'll be still stay online. If you have any question, if you want a one-on-one question or anything, you can stay after that, and then we can talk about it. All right.